Imagine missing a simple, internal usage cap at work, just a minor administrative oversight. Then, a month later, you get the software bill, and it is for $500 million.
Oh, man. I mean, I panic when I forget to cancel a $10 streaming trial. That is a terrifying administrative error. It really highlights the sheer astronomical scale involved here.
$500 million
Yeah.
just on Claude usage alone.
The
Beat. Welcome to the Deep Dive. We are really glad you are here with us today. Today, we are tracing a fascinating global chain reaction. It starts with physical hardware, and it ends with incredible digital speed.
Yeah, it is a perfectly connected digital ecosystem. We are essentially following the money and the underlying math.
So here is the roadmap for our journey today. First, we explore the Silicon Renaissance. AI hardware is triggering a staggering wealth effect in Asia. Second, we examine extreme shifts in software spending. Brute force scaling is hitting a very real economic wall. Finally, we break down a recent technical breakthrough. It proves our current hardware can move terrifyingly fast.
Right. It is a story about friction and sudden acceleration.
Okay, let's unpack this hardware boom first. People endlessly debate if AI software will actually monetize. But the physical building blocks are intensely tangible. They are reshaping real-world economies right now. It is kind of like an economic API. Every time an American tech giant queries a model, they're essentially calling a function.
A function that prints money.
Exactly. That function deposits capital directly into a Taiwanese consumer's bank account. Let's look at Taiwan's first quarter GDP growth. Their GDP growth just hit 11.8%. That is an absolute, staggering economic figure.
You usually only see that in developing nations, but Taiwan is a fully developed, mature economy. A jump like that is almost, historically unprecedented.
And this explosive growth is driven by one core metric. U.S. hyperscalers are demanding infinite AI silicon. They are buying every single chip they can find.
Right, and that corporate spending changes everything locally. Tech giants are rewriting our compensation models entirely. They are tying employee pay directly to operating profits. This is happening at an incredible global scale.
Which brings us to SK Hynix.
Yeah, SK Hynix just handed out unprecedented employee bonuses. They were equivalent to 29 months of base pay.
2 secs silence. 29 months. That is over 2 years of extra salary, just handed out as a single bonus payment. Imagine getting that dropped into your checking account.
It completely changes a person's financial trajectory, and they're not the only ones doing this. TSMC's recent bonus pool was exceptionally large, too. It averaged $82,000 per single employee. Samsung even unlocked uncapped stock awards for its chip division.
That is a staggering amount of sudden liquid wealth. It has to go somewhere in the local economy.
Right.
You cannot just hide that much capital under a mattress.
Yeah, it is flooding straight into the local consumer market. Retail sales growth in Taiwan is climbing very quickly. It is now hovering between 6 and 8%. South Korea also jumped up to 4% retail growth.
Which is huge.
It is a huge leap after a sluggish 2025. People are buying cars, electronics, and luxury goods.
So everyday consumers are spending very heavily right now.
Which creates a massive secondary ripple effect. Traditional sectors are seeing significant consensus earnings upgrades. We are talking about Taiwanese and South Korean financials.
Oh, wow.
Yeah, traditional brick-and-mortar retail sectors, too. They're all getting earnings upgrades for the rest of the year.
There is another fascinating macro dynamic happening here. Taiwan and South Korea are heavy energy importers. Usually, importing all that energy is incredibly painful, especially during global oil and gas price spikes. It drains capital out of their domestic economies.
Yes, energy dependency is usually their biggest economic vulnerability. But right now, something entirely unprecedented is occurring. They are charging immense premium pricing on semiconductor exports.
And that covers the difference.
Exactly. That hardware premium completely offsets their higher energy import costs.
They're essentially printing money with AI silicon. The premium completely neutralizes their structural energy deficit. Beat. So if the software layer hasn't fully monetized yet, how long can this hardware-driven wealth effect realistically last?
Well, it depends entirely on the capital expenditure cycle. Hyperscalers are building huge data centers for future capabilities. As long as those hyperscalers keep building, the hardware boom continues. But if those software investments do not yield returns soon, the capital eventually dries up, then the hardware demand will hit a harsh wall.
So the party ends when the data center money stops.
Precisely.
Let's move to the next link in the chain, because all that hardware creates unprecedented software usage. And that usage is causing some serious growing pains. Axios recently reported a fascinating and, Terrifying story. An AI consultant shared a billing disaster. A company missed its internal employee usage caps.
This is the Claude bill, right?
Yes. They spent almost $500 million in one single month, just on Claude usage alone.
That is $500 million in 30 days. It perfectly illustrates how brute force scaling becomes financially toxic. Companies deploy these models without strict internal governance.
I mean, I still wrestle with prompt drift myself, but a $500 million bill is another level. Companies are realizing they cannot just spend blindly anymore. Microsoft is actively cutting its own internal spending. They are cutting off external AI coding tools. Things like Claude Code are being heavily restricted.
Right, and they are pushing their own alternatives instead. Microsoft engineers are being pushed toward Copilot CLI. They are really trying to tighten AI costs internally. They want to rely on their own proprietary ecosystem.
At the exact same time, infrastructure spending is exploding.
Yeah.
SoftBank is making a colossal data center play. They plan to invest up to 75 billion euros. They are building advanced AI data centers in France.
That is an astonishing scale of European capital investment. They are aiming to add 5 gigawatts of total capacity. They expect 3.1 gigawatts in Hauts-de-France by 2031.
5 gigawatts is massive.
To put 5 gigawatts into perspective for you, that is roughly the output of 5 nuclear reactors. It shows an incredible commitment to physical European infrastructure.
So the physical infrastructure is still expanding globally, but the actual software applications are getting incredibly precise. General models are expensive, but specific models prove their worth. OpenAI and Thrive just built a self-improving tax AI.
This is a perfect use case for structured financial data. This specific tax AI agent reportedly hit 97% accuracy. It successfully handled 7,000 returns across 30 different firms.
And it boosted their total throughput by 50%.
Yeah, that is a huge productivity leap for professional accounting. It proves that narrow, specialized AI is incredibly valuable right now.
But the geopolitical layer is getting very complicated too. The U.S. just tightened rules around AI chip exports. They specifically targeted Nvidia and AMD exports to China.
There were serious ongoing concerns about overseas supply chains. Chinese firms were still accessing advanced AI chips. They were using overseas entities to bypass the existing restrictions. So the U.S. government is aggressively closing those physical loopholes.
This brute force scaling is stretching everywhere. It is pushing all the way down to consumer devices. Meta is reportedly building a brand new AI pendant. It can record conversations and analyze your daily interactions.
Yeah, it will work alongside their growing AI wearable lineup. They might launch internal testing within the next year.
Apple is also making aggressive hardware integration moves. Their AI-first iOS 27 redesign concepts are leaking everywhere online. Bloomberg reported significant user interface changes are definitely coming.
Nothing is completely confirmed by Apple just yet, though.
True. Oh, and NotebookLM finally added automatic Google Drive syncing. When a source document changes, your notebook updates too. It is one of the most overdue Google AI features. With Microsoft cutting costs internally and companies hitting $500 million caps, are we finally hitting the wall on brute force AI scaling?
We are definitely hitting an acute economic friction point. You simply cannot scale intelligence just by throwing infinite money at server farms. The focus has to shift toward radical hardware efficiency. We have to do much more with the hardware we already have.
Brute force intelligence scaling, it's officially becoming financially unsustainable. Which brings us perfectly to our final segment today. Because brute force scaling is becoming astronomically expensive, the only way forward is optimizing what we actually have. We must make our current hardware radically more efficient. Enter a fascinating engineering company called KogAI.
They are tackling the efficiency problem at the lowest possible level. They are rethinking how chips actually process information.
KogAI just dropped a stunning tech preview recently. It completely shatters our normal expectations for processing speed.
Yeah.
They hit a mind-blowing 3,000 tokens per second that was running on standard data center GPUs. We are talking about AMD MI300X and Nvidia H200 chips.
That is just absurd speed.
Wait, I have to push back on that claim. Hardware bottlenecks are very real physical constraints. You cannot just bypass physics with clever software tricks. What exactly are they doing that Nvidia themselves haven't figured out?
It sounds impossible until you look at the architecture. Nvidia built incredible hardware, but the standard software still treats it inefficiently. KogAI realized that generating text is essentially a memory streaming problem. It is not just about raw computational math capability.
It's about data movement.
Exactly. It is about how fast data actually moves through the hardware.
Let's define what we mean by tokens per second. the exact speed an AI spits out words and ideas. To put that 3,000 tokens a second into perspective, if you are used to watching ChatGPT type out answers, it normally types at maybe 100 to 300 tokens a second, but 3,000 tokens per second is practically instant. Whoa! Imagine scaling to 1 billion queries without the lag.
Exactly. It completely changes how we interact with large language models. The problem with current systems is the constant waiting. Usually a GPU forces its compute units to wait around.
Let's unpack why a GPU waits in the first place.
Well, a standard GPU has thousands of tiny cores. They all work together to solve complex math problems, but they usually have to synchronize their work constantly. They wait at broad checkpoints for other tasks to finish.
Right, and that waiting is incredibly inefficient for the system. It usually eats up 35% of the total processing time. The GPU is just sitting idle, waiting for broad directions.
KogAI changed that fundamental decoding process entirely. They wrapped it into one continuous GPU program.
It literally never stops to ask for directions. Each compute unit only waits for the exact data it needs. It is like stacking Lego blocks of data in midair. You never pause to read the instruction manual. You just keep building as the pieces fly past you.
That is a brilliant way to visualize the data flow. To make this work, they built a custom model architecture. It is called Laneformer.
What exactly makes Laneformer so different from standard models?
It allows different GPUs to talk to each other directly, but they communicate entirely in the background during processing. They do not interrupt the main computational tasks at all.
Oh, wow.
Yeah. The data flows seamlessly while the math keeps crunching.
And they went incredibly deep on the hardware integration. On AMD chips, they mapped the memory access perfectly. They matched it to the physical layout of the chiplets.
Which is how you cut latency down to the absolute bone. You are not just writing generic software anymore. You are writing software that understands the exact physical geography of the silicon. It knows exactly where the memory sits on the board.
2-sec silence. That is the biggest takeaway here for me. You have to co-design the model and the runtime. You also have to co-design the low-level GPU code. If you do that, current hardware can move terrifyingly fast.
Right.
Does this mean the future of AI isn't better chips? Is it just hyper-specific software tailored to the chips we already have?
Hardware will definitely keep improving over time, but the real staggering leaps in the near future will come from software optimization. We have barely scratched the surface of what current chips can actually do.
The biggest leaps will come from squeezing existing silicon harder. Let's take a quick break right here.
Sounds good.
Mid-roll sponsor, read placeholder.
And we are back.
Okay, let's slowly pull this whole narrative together. AI is no longer just a software abstraction today. It is a deeply interconnected physical and digital ecosystem. We started by looking at localized economic wealth effects.
Right. Taiwanese retail stores are booming because of unprecedented chip bonuses.
And South Korean traditional financials are getting huge consensus earnings upgrades. The physical demand for hardware is reshaping entire nations.
Then we saw the financial friction of the software layer. Companies are getting hit with $500 million monthly usage bills. Microsoft is tightening its belt on internal developer tools.
SoftBank is building gigawatts of power just to keep up. Brute force scaling is hitting a very real economic wall.
Which leads us exactly to the deep engineering solutions. We looked at fundamentally rewiring how a GPU streams memory.
Companies like KogAI are tearing up the old software playbooks. They're squeezing 10 times more speed out of existing hardware. They're achieving this just by rewriting the core plumbing.
It shows that innovation is happening at every single layer, from the silicon foundries all the way to the memory allocation.
It is a fascinating physical and digital chain reaction. Next time you use an AI tool on your phone, take a moment to consider the invisible infrastructure working for you. Think about the silicon built halfway across the world.
And think about the perfectly mapped physical memory architectures. It all works together to answer your question instantly.
It really is a modern engineering marvel hidden in plain sight. Here's a final thought to mull over today. KogAI just proved we can squeeze 10 times more speed out of current hardware. They did it just by rewriting the underlying software plumbing. So think about the so-called AI energy crisis. How much of it is just a symptom of inefficient code? Thanks for joining us on this deep dive. We will see you next time.
See you later.